Hey guys, welcome to 6-3. Happy Valentine's Day. There's a lot of material in this lesson. I'm going to try and talk as quick as possible so you don't have to listen for too long, but let's get straight to it. Okay, so in 6-3, we're going to be talking about creating and interpreting frequency tables, dot plots, and histograms. We've got a bit of vocabulary, and I'm going to hit all of this as I go through the notes. So just make sure that you're taking the notes and not just listening to me, because as riveting as I am, you're not just going to remember it just from me saying it. You need to write it as well and go back over those notes in order to really internalize the information. So we're going to talk about three different ways of displaying data. The first one that we're going to talk about, though, is a frequency table. A frequency table is just a chart in which we can tally or keep track of how often a particular kind of data occurs. We've given you a data set here. When you're trying to make a frequency table, the first thing you've got to do is figure out what your intervals are going to be. So when I look at this data set, my minimum value, the lowest value, looks to be 61. The highest value I see is 99. It looks like we went ahead and gave it to you in order there. So my highest one is 99. So a lot of times you'll see that you'll be given the intervals or you'll have some sort of information that tells you what the intervals should be. But for this one, we're going to have to figure it out. So I'm going to see what my range is here. So I'm going to subtract these and I get 38. If I've got a range of 38 and I've got four little blanks to fill in here, then it looks like the best thing to do is going to be to round this up to 40 so that I cover a range of 40 possible values. And then I'm going to say 40 divided by 40 divided by 4 gives me 10. So these are each going to be about 10 apart. Like I said, most of the time you're not going to have to do this part. You'll be given what the intervals should be. So I'm going to start with 61 and go up to 70. That's going to cover 10 data values. And then this one is going to start with 71 and go to 80. Really, there's not a lot of rules about how you make those intervals. The only rule is that all the intervals are the same. You want them all to be about the same size. So this one's going to go 81, 90, and then this one's 91 to 100. You also want to make sure that whatever you choose your intervals to be, it covers all your data points. So it's okay that it goes a little bit past my highest as long as all my data points are covered. And it's as close to equitable as can be, because I started at 61, which is right on this data, and I went just barely past. So I think these intervals are a pretty good representation of what I've got. So now it's just a matter of tallying. I've got one in the range of 61 to 70. I've got another one in the range of 61 to 70. 81 is going to fall right here. 83 falls there. 87 falls there. 88 falls there. 89 falls there. And 90 falls there. So let's see if I got that right. 1, 2, 3, 4, 5, 6. Yep. All right, and then I've got 98 here, and I've got 99 here. So that's my frequency table, and that's literally all there is to frequency table. The method of displaying data is called a dot plot. A dot plot is constructed by just drawing a number line and placing a mark each time a data piece occurs. So again, it's kind of like just a tally, but it's going to be a more visual representation so you can see the differences there. We got our cute little dot plots. When I was in the 4th grade, I lost a tooth in a dot on Halloween. So let's go ahead here. And it looks like my lowest data piece is a 1. My highest is a 9. So I'm just going to make a number line. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got a nice long number here, but I don't need it to be that big. So 1, 2, 3. Label it. We say it's on a number line. It's not always going to be on a number line. It might just be on a line with labels. Because dot plots can be done for things other than numerical data. It could be something that's got, I don't know, favorite color or something, and you could have X's. But now I'm going to say As I go through, I'm just going to place a mark each time. So I've got a 2, so I'm going to put a 2. I've got a 1, a 4. This is really boring to watch me do, and I'm sorry. I'm going to do a 5. I'm going to do a 4. You get the idea. I'm going to do a 6. I'm going to pause it and finish this up, and then we'll come back and talk about it. All right, so there's my completed dot plot. You can see that there are 22 pieces of data if you count here, and I've got 22 marks. A couple of things that I've noticed over the years that students tend to mess up. A lot of times on statistics tests, we'll give you a dot plot and then we'll ask you questions about it. Like we'll ask the range. And so you'll need to say, well, my highest mark here is a 9, my lowest is a 1, so my range is 8. Or we'll ask you the average or the mean. If I ask you the mean, then you would need to say, I've got 3 1s, so you would need to have a 1 1 1. You would need to have 4 2s and 3 3s. You would have to list each mark is a piece of data. A lot of times you'll see kids just add up these numbers and then divide by 9. That is not going to get it because you've got more than 1 2. You've got more than 1 3. So that's something that people tend to mess up. Otherwise, it's pretty self-explanatory. So let's go on to the next. All right, I kind of hinted at this a moment ago, but frequency tables and dot plots can both be used to display or summarize categorical data. And they can also be used to display quantitative variables. So categorical variables are variables that include names or labels and things like colors or shirt sizes or letter grades or stuff like that. The example I gave was your favorite color. You could do a dot plot where I take a vote of what everybody's favorite color is and each vote gets a mark or whatever. That would be a categorical data. I wouldn't be able to find the average color. It'd just be brown. Numerical variables or quantitative variables are numerical things that represent a measurable quantity. So that's like the dot plot we just did where you had a number for each piece of data, and we can do some extra analysis on that we can't do with categorical data because we can take averages and things like that. So we have an example here of a categorical data set. A school club is ordering t-shirts and we're gathering sizes. We want to do a frequency table and a dot plot to represent the shirt size data. All right, so for the frequency table, it's a bit easier this way because I don't have to think about how big my interval is going to be or anything like that. I'm just going to have my categories as my intervals. So I've got small, medium, large, extra large, and extra, extra large, okay? And I'm just going to tally them up. I've got 1, 2, 3, 4, 5, 6 smalls. Sometimes you'll see it written with just a number. Sometimes you'll see it written with tally marks. Be prepared for either one. Got to be flexible. Medium, I've got 1, 2, 3. All right, I'm going to pause it and finish it up, and I'll be right back. All right, so all I did there was count through the rest of my data. You can see that my mode here is small. The most people had small. And then the runner-up would be extra large. But like I said, all I did was count. That's the frequency table. The dot plot, again, as I said a moment ago when we were first introducing dot plots, you don't have to have numbers along this, so it's not fair to call it a number line. Instead, we're going to just call it a line where we've got our labels for our data. So I'm going to have small, medium, large, extra large, and extra, extra large. And with a dot plot, you're just making a dot to represent each piece of data. So you would go through and say, I've got a small, I've got a large, I've got a small, I've got an extra large. This time I'm making dots instead of X's. Why? I don't know. Sometimes you'll see dots, sometimes you'll see X's. You never know. Good mathematician is a flexible mathematician. I've got an extra large, another extra large, double XL, another small, medium, large, large, extra large, and extra large. All right, so there's my dot plot that represents this frequency table. Frequently, pun intended, not intended, you will see histograms right next to frequency tables or frequency tables right next to dot plot because it's just different ways of representing the same information. Notice I've got 6 dots here to go with my 6 smalls. I've got 3 mediums, 4 larges. It matches up with what you see here. All right, we're going to talk now about histograms, which is our last method of displaying data that we're going to talk about today. A histogram is a graph that groups data into intervals. Again, we're going to use frequency tables to help us with this. And then we use rectangles to display the frequency of data within those intervals. It's similar to a bar graph, but there are some key differences. Frequency tables are used to help us set up the histogram. The limitation of a histogram that the other two don't have is that it is only used for quantitative or numerical data. All right, so I've got a histogram here. I've got a shell of a histogram, and I've got some data that I want to try and put on my histogram. So again, we're going to have to figure out our own intervals. I've got my lowest value is a 68, my highest is a 98, so that's going to be a range of 30. But again, I've got 4 blanks to fill. You could choose to only use 3 of those, but I'll show you what to do if it doesn't quite fit what you need it to be. I'm still going to do intervals of 10, I think. I'm going to start with 61 and go to 70. 71 and go to 80. Really, guys, when you're displaying data, you're the boss of it. You've got to find a way to display it that fits the data you've got, that will work for what you need. And this is going to cover me. I'm going to be a little bit below my lowest here, but I'm going to be above my highest. So I'm going to stick with that. If you ask Mr. Thomaswick or Miss Smith and they have a better way of doing that, let me know and I'll fix the video. But for now, 61 to 70, I've got 2. I've got 2 pieces of data there. 71 to 80, I've got 1, 2, 3, 4, 5, 6, 7. 81 to 90, I've got 1, 2, 3, 4, 5, 6, 7. 91 to 100, I've got 1, 2, 3, 4, 5. All right, so then once I've got my frequency table, what I'm going to do is I'm going to label my intervals on the histogram graph. So this one is going to be 61 to 70, and then 71 to 80, 81 to 90, and 91 to 100. 91 to 100, not 9 to 100. And then I'm going to draw a bar that goes as high as my numbers indicate they should. So on this side, you're going to have your frequency table. Here are going to be your intervals or your bins. And I am going to do a rectangle that goes up to 2 because it said that I had 2 between 61 and 70. My next bin starts right after this one ends. So from 71 to 80, I'm going to have a rectangle that goes up to 7. And then it's going to go down. They should be about the same size. I'm not the neatest person, and I don't have a ruler on my computer. Well, I do, but it would be a pain to use it. And then 81 to 90 has 7, and then 91 to 100 has 5. So I've got this. And then I'm going to go in and color it in just to make it look pretty. But they should be ending right after each other. They should be touching. That's one of the key characteristics that makes this different from a bar graph. So you will lose points and you will get it wrong on a multiple choice if you choose something that has gaps in between the rectangles. Okay, you should not have that. And that's really it with histograms. Ooh, look at that pretty color. That's really it with histograms. So we're going to talk some more about shape and how we can analyze and interpret these once we've made them. But maybe go ahead and stop and do some practice now. And I'll stop as well before making the second part of the video to get you that analyzing part of things. All right, good night.